Hello, this is Valerie Shirley. Welcome to my demonstration video. Today I will be demonstrating the one-way ANOVA. So let's go ahead and get started. So what we've been asked to do in this module is to conduct a one-way ANOVA with post-hoc tests if necessary, to compare staff satisfaction scores across 3 levels of length of service. So the first step in hypothesis testing is to pick a test. The prompt has already told us which test to perform, the one-way ANOVA, so we can move forward. And of course, we know that ANOVA means analysis of variance. And we have multiple levels within our independent variable, more than 2. So a t-test is not applicable. The independent variable is the length of service, which is divided into 3 groups. The 3 groups are 0 to 2 years of service, 3 to 5 years of service, and 6 or more years of service. The dependent variable is staff satisfaction scores, which are to be measured at scale. So no means can be calculated. All right. The second step is to check the assumptions, and there are 4 assumptions for an ANOVA. Assumption number 1 is random samples. Number 2, independence of cases. 3, normality, and then 4, homogeneity of variance. So our first assumption, random samples. The sample is not random because all staff members were asked to participate, but there are more than 30 participants, and so it is robust. So we can move forward. Number 2 was the independence of cases. Each staff member responded individually without influence, so that assumption is met. And then we get to our third assumption, normality. And I have used, haven't done much calculating yet, let me see, but I did create a histogram with the data, and I'll show us how we got there in a minute. But we can see that the majority of our data is within the frequency distribution. So yes, normality is met. And then step 4, homogeneity of variance. And we will not know if we've met this assumption until we run the ANOVA in SPSS. So again, first we're going to check for normality. And so what we do there is to go from analyze to descriptive statistics, and then frequencies. And from there, we are going to move the total staff satisfaction scale into the variables box. We can see that I've already done that. And then under charts, we select histogram, and I click the box, show normal curve on the histogram. And so once we've done all of that, we get this information right here. Okay, so again, most of the data fit underneath, just a sneaky little outlier right here. This is a minuscule outlier. This guy's a little more brave. But anyway, all of our data fits under the frequency distribution, and so it shows normality. Okay, so now we need to move on, and we need to run the ANOVA so that we can check that 4th assumption. So to do that, what we're going to do, I'm going to do it with the data. versus the output chart. So this time we're going to go to Analyze. Then we go to Compare Means. From Compare Means, we go down here to One-Way ANOVA. And this is really involved. So I had to use my thinking cap quite extensively. Okay, so in the One-Way ANOVA box, we're going to move our dependent variable, which is total staff satisfaction scale, over here to the dependent list. And the independent variable is going to be the length of service. And so we're going to move length of service into the factor box, and we can see that I've done that. And then we select options. And from the options, we're going to select descriptives or descriptive homogeneity of variance test, Brown-Forsyth, and Welch. And we also want to check means plot. And finally, we need to make sure that this box exclude cases analysis by analysis. So we've done all of those things. And let's see. So then we would click continue. But I already did that. So let's move on. We also are going to go ahead and run the post-hoc. We only need it. We may need it. So let's just go ahead and run it. And so we're going to go ahead and select post-hoc. And from here, we just select Tukey. And then we continue on. And then we're back at our main box again, and we are going to click OK. All right, and I'm going to go ahead and exit out of this and pull back up my output box. And we've got all the data created. In fact, here's the histogram that we've talked about. And then here is when I ran some data wrong. And so right after this frightening chart that was completely wrong, I could see that right off the bat, we went ahead and ran it again. So here is all the data, again, run correctly with the correct dependent and independent variables. Okay, so step number 3 is to list the hypotheses. So our null hypothesis is going to be all 3 of the population means will be the same. And the alternate hypothesis is that at least one population mean is different from the others. Okay, so we've got our hypothesis. And step 4, in step 4, we are going to set the decision rule. This is also pretty involved. I referred to Cordy, chapter 10, page 366, and just followed it very closely. But in this step, we find the critical value of F, which is the value that separates the rare zone from the common zone of the sampling distribution. The decision rule is if F is greater than or equal to the critical value of F, we will reject the null. And if F is less than the critical value of F, we will fail to reject the null. All right, so to find the critical value of F, we are going to use K minus 1. And K is the number of groups, and we have 3 groups. And N is the number of cases or participants that we have. So K minus 1 determines the degrees of freedom for the numerator. So that is what our numerator is, K minus 1. And N minus K is used to determine the degrees of freedom for the denominator. All right, so boiling that all down, the numerator is K1, which is 3 minus 1, and that's equal to 2. The denominator is N, which is 435 total, minus K, and K was 3. So our denominator is 432. And we carry on a little bit more with this step. Okay, it is important to know both of these numbers. because we will be looking at the appendix in the QWERTY text, A12. And so we will be looking at that chart. We will look at the intersection of column 2 and the number 432, the numerator and the denominator, to get the critical value of F, and that is 3.018 from the appendix A12 chart. Okay, so the decision rule is if F is greater than or equal to 3.018, we will reject the null. If F is less than 3.018, we will fail to reject the null. 3.018 is used to separate the common zone from the rare zone. And we are now at step 5. And step 5 was to run the ANOVA, which we did. And remember, not that scary chart beginning right here. It's where we have run the one-way ANOVA. All right, so our final step, interpreting the data. Step 6 is interpreting the results and checking assumption number 4 to start off with. So assumption number 4 was homogeneity of variance. So to check assumption 4, we're going to look at Levine's statistic, and let's scroll down. All right, hang on. I'm looking at where my Levine statistic is. I knew where it was 30 seconds ago. There we are. Oh, there we are. Okay. I was expecting it to be in the front here. All right. Here is my Levine statistic. All right. And it is under the test of homogeneity of variances. And I had written myself a note about that, and then I totally forgot it. Okay. So if this list of numbers under the Levine statistic, if the numbers are greater than 0.5, assumption number 4 is met, and we can see that they all are. They're all greater than 0.05. All right, so now checking the interpretations. All right, we have 3 questions that we need to deal with. Question number 1 is, was the null hypothesis rejected? And so we're going to look at the ANOVA chart right here, and we can see that F is 5.902. The number we're comparing it to is 3.018, and 5.902 is greater than 3.018, so we will reject the null hypothesis. All right, F falls in the rare zone, which means at least one of the 3 groups differs in mean satisfaction, and this indicates statistically significant differences. All right, so question number 2 then is, how big is the effect? And so to find out that, we calculate R squared, and we use the sum of squares information in the ANOVA chart. So right here, the sum of squares. We take the between the groups value, and we can see that right here, between the groups value of 557.061, and then we are going to divide it by the total, which is this huge number down here, 20944.069. So we divide 557.061 by the 20944.069, and then we multiply it by 100, and that gives us 2.6598. And then we multiply that by 100 to get our percentage. And the percentage is large. We have about a 265% in our effect. So, wow. And we'll be able to see that in just a minute. Where is the effect? This is question number 3. And where is the effect? And for this, we need to run the post-hoc test. So thank heaven we did that. Okay, so we are going to, in our post-hoc, right here, under Tukey, and here we have Tukey right there, we can see that the group with 3 to 5 years, this one right here, and the group with 6 or more years, this one right here are significantly different than the group with just 2 years. This right here. All right. Very different. Okay. So now let's scroll down and look at our means plot. And in our means plot, we can see here are our employees with 2 or fewer years, and their satisfaction is a little above 35.5. And then we move down here to our employees who have 3 to 5 years experience, and they are clear down here, and we can see that the employees with 6 years or more experience are just a little bit less than the 3 to 5. So we do see this huge effect right here. All righty. So in conclusion, our one-way ANOVA and post-hoc tests have revealed that employees with 2 years or less work experience had satisfaction ratings that exceed those with 3 or more years of experience. And this concludes my demonstration video. Have a great day.